So the graph on the paper is showing the visual spectrum from ultraviolet to infrared, and it's showing the wavelengths of the different light patterns or light frequencies. Now it turns out that when light of different frequencies goes through a prism, each one reacts differently to the refractive index, and the wavelength change will cause uh, the angles to be different, and you get this spreading or dispersion of the light rays coming out of the medium. This is the same thing that happens basically when you see a rainbow, where the sunlight is entering and the different frequencies of the light come out at different angles, and you see different colors of the rainbow. So let's come up with a formula that allows us to understand the wavelength based on the refractive index. So we have the wavelength of some refractive index is equal to the velocity divided by the frequency. Now the velocity is the velocity the light is traveling in the medium. The frequency is always going to be the same. It does not change whether it's in the medium or in a different medium. The frequency is always the same. Now I can substitute in for the velocity using the refractive index. Remember that this formula is n equals c over v, and if I solve for v, it just becomes c over n times the frequency, and c divided by the frequency is just the wavelength in a vacuum, and I'm going to have that wavelength divided by n. So now we can calculate the wavelength of the light through a medium based on the wavelength in a vacuum divided by the refractive index.